Think about the coastline you know and love. Well, I've got some news. It's not permanent. Over the coming decades, it's going to change in a big way. We're talking about sea level rise, and it's not just happening, it's actually speeding up. And in this explainer, we're going to dive into why that is. But let's start with a kind of provocative idea. What if I told you that, to some extent, the future of our coastlines is already written? What if the things we did decades ago have already kicked off changes that we just can't stop anymore? I know, it sounds like a movie plot, but the science here tells a really fascinating and pretty sobering story. Okay, so here's the first real shocker to wrap your head around. Even if we somehow miraculously stopped all carbon emissions today, like right this second, the seas would still keep rising for a long, long time. So why is that? Well, it's because of a huge time lag. It takes literally centuries for the deep oceans to finally catch up and react to all the heat we've already trapped in our atmosphere. So you might be asking, how on earth do we know that? Well, scientists basically become climate detectives. They go to places like Antarctica and Greenland and they drill deep into the ice, pulling out these amazing ice cores. And trapped inside are these tiny ancient bubbles of air from Earth's past. Those bubbles tell us a crystal clear story. The last time CO2 levels in the air were this high, the planet eventually found a new balance point, a much, much warmer one. And that future balance point comes with a number that is just, it's hard to even comprehend. 10 meters. That's more than 30 feet of sea level rise in the long run. And get this, that's not some crazy worst-case prediction. That's the potential future that's already locked in by the CO2 we have in the atmosphere today. Now, it's going to take centuries for it all to happen, but that's the direction we're pointed. So let's try to actually picture what 10 meters means. It means the White House is now waterfront property. It means southern Florida is pretty much gone. Huge major cities, we're talking Shanghai, Bangkok, Buenos Aires, they'd be lost to the sea. Almost the entire nation of Bangladesh would be underwater. It is quite literally a remapping of the world. And this isn't just about lines on a map. It's about people. About 1 billion people, which is roughly 1 out of every 8 of us on the planet, currently live on land that would be underwater with that kind of rise. We're talking about a potential migration crisis on a scale humanity has just never seen before. A future with 10 meters of sea level rise is, a shocking thing to think about. So what's the actual science driving all this? Well, it really just boils down to 2 pretty simple but incredibly powerful physical processes. So for a long time, these 2 things were kind of equal partners in crime. First, you've got thermal expansion. It's just basic physics, right? When water gets warmer, it takes up more space. And second, you have ice melting from glaciers and the big ice sheets. But recently, that whole balance has completely shifted. The melting of the massive ice sheets in Greenland and Antarctica has hit the accelerator, and now that's the main driver. It has become the dominant signal. And honestly, this is the part that keeps scientists up at night. As one expert put it, the real elephant in the room is the ice sheets. We know for sure that they're melting faster than we thought they would. But the huge question mark, the big uncertainty, is just how fast are they going to go? And could they hit some sort of sudden tipping point? Okay, so that long-term view is absolutely staggering. But let's pull the timeline way, way in. What can we expect not in a few hundred years, but in our own lifetimes? Because the projections for the next 30 years are actually a lot more certain. Just take a look at this chart. It tells a really clear story. In the last 30 years, the oceans rose about 4 inches. Now, look at the next 30 years. We're on track for a foot, for 12 inches. So the big takeaway here isn't just that the seas are rising. It's that the speed, the rate of the rise, is speeding up a lot. So let's just put a really fine point on it. By the year 2050, we are pretty much locked in for 1 foot of sea level rise compared to where we were in 2020. And I want to stress, this isn't speculation. This is one of the most solid projections in all of climate science. Now, I know what you might be thinking. 1 foot. It doesn't sound nearly as dramatic as 30 feet, right? But its impact is going to be enormous. Think of that extra foot of water as a new, higher launching pad for every single storm surge and every high tide. It pushes floods higher and farther inland, and it's going to turn floods that used to be rare into common events for people all over the world. So if that 1 foot by 2050 is more or less baked in, what happens after that? Well, this is where the story splits. This is where we are right now, standing at a fork in the road. And the path we decide to take today is going to define the world our kids and grandkids see in the year 2100. This table kind of lays out the two futures ahead of us. If we stay on our current path, we're headed for about 3 degrees of warming and maybe 3 feet of sea level rise by 2100. That's a profoundly changed world. But if we go down a high emissions path, we're looking at 4, 5, or even more degrees of warming and at least 4 feet of rise. That's not just a changed world. As you can see, that's a scary one. And when you hear climate scientists use a word like scary, it's time to pay attention. At that level of warming, we start getting into what they call unknown unknowns. We're talking about nightmare scenarios like a rapid collapse of the West Antarctic ice sheet that suddenly become terrifyingly plausible. We just can't take that possibility off the table. And even if we stick to our current most likely path, just look at how this plays out. That 1 foot of rise we see by 2050, it grows to 3 feet by 2100. But here's the crucial thing to understand. It doesn't just stop there. The momentum keeps going. And by 2150, we could be looking at 6 to 7 feet of sea level rise. And all of this brings us to the final and most critical point. Because while some amount of change is definitely unavoidable now, our future is not completely set in stone. We still have a very real choice to make. Let's just be really clear with ourselves. Our coastlines are going to change. That part of the story is no longer up for debate. The only question that's left for us to answer is, by how much? And believe me, the difference between a future with 3 feet of sea level rise and a future with 7 feet, that's everything. It's the difference between a world we can probably manage and adapt to and a world of chaos. So the big goal that scientists and world leaders are aiming for is something called net zero. You've probably heard that term. All it really means is getting to a point where we've cut our emissions so much that any little bit that's left over can be balanced out by actively removing carbon from the atmosphere. And the amazing thing is, we know how to do this. The pathway to net zero just involves speeding up things that are already happening. A super fast switch to solar and wind power, a huge build out of batteries and energy storage, going all in on electric vehicles, and getting smarter about our global food systems. The tools we need aren't science fiction. They are here, right now. So we end up right back where we started. But now we can see the whole picture. Change is coming to our coasts. That's the inheritance we've been given from our past. But the size of that change, the difference between a future we can handle and one that's catastrophic, that's the choice that we're all making, together, right now. So the question on the screen isn't just for politicians or CEOs. It's for all of us. What future will we choose?